Okay, you can see the shared screen from my laptop. This is the chapter number 2 that we have started from the last few chapters, few lectures. Then Okay, in the last lecture we are discussing about the operating system structures. Okay, in last lecture we have seen the structure for the MS-DOS, then Unix operating system, and we have seen the diagram for the layered operating system structure. Are you able to see the screen, Swapnali?
Yes, sir.
Okay. Operating system structure in this, okay, we have seen the simple structure for MS-DOS, also for the Unix, okay, and the layered approach given by the MS-DOS. This diagram we have discussed in the last lecture. This is the simple structure provided by the MS-DOS. Then the non-simple structure provided by the Unix operating system, that also we have discussed in the last lecture. This is the diagram for the Unix operating system structure. We have seen the kernel present at the bottom of this diagram, which kernel is directly going to interface with the hardware, and on top of that the shell command compilers, interpreters are present into the user mode, and user is going to operate with that one. Okay, then now from here we are going to start for the today's lecture. This is nothing but the layered approach. So we have discussed yesterday about the layered approach, but what it actually means, that we have to understood what it exactly means, the layered approach. The layered approach, in the diagram you can see that, just a minute. In the diagram you can see that the number of layers are divided from hardware layer, that is nothing but the layer 0 is nothing but your hardware, and as you move further, that becomes a layer number 1, layer number 2, layer number up to n. So what the things, how we are going to access the functions for the any of the layer. Okay, here the simple thing is there, when we are present at the layer n, the layer n can only access the function of layer n minus 1. Means we know that this is the layer number 1 and this is the layer number n minus 1. Okay, then when I want to I cannot directly interact with the hardware here. Okay, suppose I want to interact with the hardware, then I should go to the this sequence. Means first of all layer number n is going to access the layer number n minus 1, then n minus 2, and then up to the 0th layer. So this is the idea behind the layered approach. Okay, that is given into these all the points. The top layer is nothing but the n, and up to we are going to move to the layer number 0 is nothing but your hardware level. Okay, so what it exactly means. Okay, in this slide you are going to see the actual layered approach given by the any kind of a operating system. For example, we are going to take it here as a Unix operating system. Okay, so such as the layer here, the hardware is present here, on top of that the kernel is present. Okay, then on the above layer all the shell, okay, you can go you can view this shell is going to be present here. Okay, and then these all the commands we are going to use for the different purposes to serve our need. That is nothing but the ls is there, sort is there. Suppose I want to list the files, then I am going to use the ls. I want to sort the files, then I am going to use the sort. When I want to see the users, those who are logged in, that is nothing but the who command. When I want to zip the command or zip the files, then I am going to use the tar command. When I want to search any kind of a pattern, then I am going to use the grep command. So this is for the copy command. So there are the number of commands are present into this layer. Yes, and when the user is directly going to interact with the application layer, that is nothing but the topmost layer or the N layer. So we have discussed in the previous slide, that is nothing but the N layer can interact with the n minus 1. Okay, here the n is nothing but the your application program. When I want to access some kind of a services, okay, when I want to access the hardware, then I am going to use the interact with the n minus 1. So that is nothing but the shell. Okay, and this is the n minus 2. When shell is interact with the kernel and the kernel is interact with the hardware, so this is nothing but the layered approach provided by the any kind of a operating system. Okay, here we are taking the example as a Unix. Okay, so I think most of the students have clear idea about the layered approach given by the any kind of a operating system. Then if you have any doubt, then you can ask about this one, or we will go to the next slide. Okay, we have seen that the in the system calls, how we are going to invoke the system calls. Any one of you? Okay, just I want to
Using
say using
API.
API. Very good. Okay, so API is present at this layer. Okay, API is present at this layer. Okay, and your system calls is present at this layer. Okay, here the system calls are present. So when API is at the top layer and your system call is at the n minus 1 layer. So when and it is going to execute at the kernel level, and this is at the user mode. API is at the user mode. This is at the kernel mode. And when you want to you want to access the any kind of hardware, so this is nothing but the layered approach. Okay, this is the example for the layered approach. When the user is here, okay, he wants to shut down the machine. Okay, for example, or simply you can take it as a he wants to copy the file, then user go for the API, then user go for the system call, and then it is going to access the hardware and input output. So this structure is nothing but the layered approach. Okay, so I think most of you have the clear idea about the layered approach. So it has the some advantages, such as the layered approach is easy to understand and easy to maintain also. Then it allows user to use services of the lower layer. Okay, so what is it mean by that? N is going to access the services from the n minus 1. So that is nothing but the use the services of the lower levels. Then this is the simple architecture to understand. This is the another advantage we can say. Then debugging is easy in layered approach. So when we think about the any kind of a error is coming from that layer, so we can debug only that layer. So we can say that you all of you know that what is meant by the debugging, just like a C program. So just like we are debugging the C instructions or the C program lines, such thing we can consider for the debugging the any kind of a layer. Then there is a no complicated construction at the execution provided for the any kind of a layer. So these are the some advantage with the layered approach. So which are the disadvantage? We also know that when the advantages come, so for every architecture everything has the some advantages and disadvantages. So disadvantages is just like that it cannot carry the big task. because of the limitation of the layer. So when we are taking the most of layers, so big task cannot be carried out by the such kind of a structure. Then new functions, new layers need to be formed. Okay, this is the very old one. So for the newest architecture and the need, we need to create the some of the new layers. So there is a no definition given for the how many exact layers are in the layered approach. Okay, so that can be a depend on the structure of that OS and who is designing that OS and how they are going to implement that one. So this is the very old structure that is present into the 1960s, and the modern operating system cannot be suited into this layered approach, so they can go for the another kind of a structure. Okay, so this is about the layered approach provided by the Linux operating or the Unix operating system. Then we will move further to the some of the two key concept, that is nothing but the types of the kernel. So we know about the kernel, what is mean by the kernel, what the kernel does. Okay, anyone can give me the definition for the kernel? Then we are going to understand the types of the kernel. Any one of you?
Kernel is a heart of the operating system.
Okay, it is a this is the very general definition. The kernel is the heart of the operating system, and instead of when we say the operating system is doing the all the tasks, behind that kernel is doing the all the tasks. Okay, so the kernel we are having the two types of the kernel. One is a microkernel and second is the monolithic kernel. So what the exact difference between the microkernel and the monolithic kernel? Okay, we will see one by one. The first one is about the microkernel. Okay, as a history we can say in 1980s the researcher at Carnegie Mellon University developed an OS called as a Mac using the microkernel approach. Okay, when they are developing this operating system, okay, at that point of a time they have uh, made some kind of an approach that for the kernel, that is nothing but the microkernel approach. Then removal of unnecessary component from the kernel, and they are implemented as a system. Okay, so always you have to remember that the some kind of a things that is included in the kernel mode. Okay, so many of the drivers are there. Then some kind of scheduling things are there, and many of the things are the normal kernel, we can say it is a monolithic kernel, are doing into the kernel mode. But here what they have done, so these tasks are they are going to move it into the user area, so that is nothing but the microkernel. So what it makes, then it results into the small kernel, so we can say it as a microkernel. Okay, why it is, sorry, why it is going to be a microkernel? Because the task those are moved that are performed in the user areas, they are going to move it. Why it is an unnecessary component? So we can think that we are going to move the many of the components to the user mode, or the unnecessary components are going to be removed. Means we can say this kernel is going to be a application based. It is, this general is not a general kernel, or because we are going to move the things that are not going to be used in the system, they are going to remove it, and some kind of thing they are going to move it to the user mode. So it, the kernel is going to be small, and kernel is going to be efficient and the fast. So that is nothing but the microkernel. Then provides the minimal process and memory management facility. So the tasks are very less, or the application dependent, so the process management and the memory management is also going to be less here. Then it provides the communication between the client program and the various services. Okay, whichever the client program is running and he want they wants to access the services, they are going to be provided by the this kind of a kernel. Then there is a communication between the processes, how the processes is going to communicate, it is by using the message passing uh, concept. Okay, so what is actually mean by the message passing? that we have discussed also, but you just remember that the message passing is nothing but it is a communication for the between the processes. So that is nothing but you just remember that one. Then OS can port from one hardware to another easily because it is a microkernel. So we can move from one hardware to another hardware easily. Then provide the more security and reliability. So why here they have provided the more security and reliability? Because when any kind of a process or the any kind of a program that are going to be executed in the kernel mode, so that is under the kernel, we can say that is under the kernel. So uh, kernel observation, kernel mode observation, so they are going to move more of the things into the user mode, so they need to provide the more security and reliability, so user can does anything at the any point of a time. So they need to provide the more security here and more reliability here. Then example of the microkernel is nothing but the QNX operating system, True 64, and Windows NT. So the most of the Windows operating systems are based on the monolithic kernel, but the Microsoft tried it with the Windows NT, but unfortunately, it is going to be failed. That is based on the microkernel, because we know that for the desktop of operating system, the monolithic kernel is going to be best if they are going to be used in the system. So these are the few examples for the microkernel, and at the last point in the presentation that is given as the microkernel moves. This is the definition for the microkernel. Microkernel moves as much from kernel to user space that we have discussed. The many of the things that are going to be we are making it into the kernel mode, that we are going to move it into the user mode, and the communication between the user modules or the processes are done by the message passing communication. So this is the points related to the microkernel. Okay, we will see which are the benefits with the microkernel. So it is easier to extend, so it has the minimum functionality, so we can extend it based on the applications. This is the benefit number one. Then easier to port, such as a small in size, so we can move it from another one hardware to the another hardware platform, so it is easier to port. It is a more reliable and secure. So these are the some benefits comes with the monolithic kernel. But you always remember microkernel, but you always remember that the microkernel is an application based for many of the tasks, such as a desktop system. On the desktop system we are going to run the Microsoft Word. Then you can listen the music at that point of a time. Then you can do the some kind of a editing. You can do the many things at a one at some uh, at the same time. But the in the microkernel that is not possible, because it is a application based and it is going to be derived for some kind of a application only. Then here in this slide you can see the difference between the monolithic kernel and the microkernel. Okay, so here in the diagram I will show you. Okay, the kernel is going to be small. Okay, and the file system, process server, pages, drivers, these all things are moved into the user space. Okay, here it is a user space, so you can see here is the huge user space is there and small kernel space is there in the microkernel. Okay, and here in the monolithic kernel you can see the user space is small, where only the application and library is there, and in the kernel space all the things are going to be executed, like a file system, inter-process communication, input output management, and fundamental process management. So these all the things are executed in the kernel space. So this is the basic difference between the monolithic kernel and the microkernel. We will see the difference rigorously also in the next few slides. But this is all about the microkernel. So I will finish first of all the monolithic kernel also, and then we will discuss again for that one. Then we will move to the monolithic kernel now. It is a common approach for all the operating system, can be referred as a big mess. So why it is going to be called as a big mess? So we have the number of tasks to do. For every task they are going to return the procedures, they are going to compile the procedures and the parameters related to it, and after that they are going to be bind it. So when the one of the user is going to copy something, then that copy system call through API is going to be called and the thing is going to be done. So this approach is nothing but the monolithic structure of the operating system. So this is the diagram where I have taken it from the net, from the book of the Tenenbaum. This is the kind of a good book that is referred for the operating system. Uh, and here you can say this is the main function, OS services are there and utility functions are there. So this is the modular approach, one by one we can go and we can do our task. So this is nothing but the monolithic kernel. This is the common approach, we can say it is a big mess. Then next point is about the collection of procedure, each of which can call any one of other ones, and whenever it needs, anyone can call any kind of a function. This function can call this one can call this one, this function can call this one, depend on the needs. Okay, so this is nothing but the monolithic kernel, and it is a well-defined interfaces in terms of the parameter procedures and the parameters. Then compiler is going to compile all the services or the procedures and going to bind it, and whenever it is needed it is going to be called. Information hiding is performed in the monolithic kernel. So there are the different kind of procedures is going to be written, then different kinds of the functions packages is going to be written in the operating system, but it is going to be hidden from the user don't need to worry about the which exact thing is going to be written into some kind of a functions or the packages. So this is nothing but the monolithic kernel. We have the some few points related with the monolithic kernel. You can write or you can draw the diagram here for the monolithic kernel. Okay, in the next slide. Okay, this is the exact comparison between the microkernel and the monolithic kernel, and on which point we are going to compare, this is given in the left side. Okay, as this when we compare the size, then the size is about the microkernel. Obviously, as the name suggests, it is a smaller one, where this is the larger one. As a execution, this is the slow execution is performed by the microkernel, and where is monolithic perform the fast execution. As the extendable, when we want to extend the any kind of a kernel, so it is easy to extend, it is hard to extend. Security, okay, if service crashes it does not affect on the kernel. Why? You can now you can tell me that why this thing is going to be happen. If the service crashes, the microkernel is not going to be affect more, whereas the service crashes, the monolithic kernel is going to be crashed. Okay, I want answer from you, all of you, that why this is going to be happen. We have discussed the structure, so you can give me the answer about this one. Then code, okay, to write a microkernel, more code is required, whereas less code is required. So why they have given this point is about the monolithic kernel can take the different procedures from the ready codes and ready packages. It can be included in the monolithic kernel, so we can bind it easily. So example they have provided QNX, Symbian OS, L4 Linux, whereas the Linux, BSD, OpenBSD, NetBSD, these are the examples for the monolithic kernel. Okay, the Symbian OS, I think you have heard, I also told you why we are using the Symbian OS. Any one of you? Priyanka? Use of Symbian OS?
नाही माहिती सर.
Mm, Tanvi? Okay, the Symbian OS, it just like a your mobile operating system, just like a Android. At the when the mobiles are started, the Nokia company is going to use the Symbian OS. So many of the mobile companies are going to use this one, but Android operating system is going to be more become popular and popular in today's days. So many of the mobile companies are using the Android operating system. These are the few examples for the microkernel and the monolithic kernel. So this is the exact difference between the microkernel and the monolithic kernel. So this is the important for your paper also. In many cases, the comparison is going to be asked. Okay, so this is about the today's lecture. We have to discuss about the layered approach, and we need to complete the conceptual things behind the microkernel and the monolithic kernel. In next lecture, we will going to talk about the system components activities like a process management, then memory management, file management. What exactly is going to be done into such kind of activities? Okay. For today's lecture, we will stop it here.